My name is Rohit of Big Scholars Academy, and today I am going to teach about optics. Topics which we are going to discuss today are about smooth and rough surfaces, and about plane mirror and its effects when light is incident on it, and loss of reflection, and about multiple reflections. First of all, about smooth and rough surfaces. Smooth surfaces. Let this be a surface A, B, and a light ray is instanted on it and it gets reflected. Let this be O, X, Y. Here, two things happen. One, some of the light is absorbed, and second one is other left out light is reflected like this. It is instanted and it is reflected, and this is the normal to the plane. Now let us learn about rough surfaces. Let A dash B be a rough surface and X O be an instant ray and Y O being reflected ray. Let this be X dash and Y dash. Now see here, in a smooth surface, when XO is instanted and YO gets reflected, here this is known as angle of instance and this is known as angle of reflection, right? You got it wrong. Here this is the angle of instance and this is the angle of reflection. Here in the case of smooth surfaces, angle I equal to angle R, but in the case of rough surfaces having a normal and dash, this is the I and this is R. I is not equal to angle R. In ray optics, we consider only smooth surfaces. Let's go to the other application of ray optics, that is the plane mirror. Now to talk about plane mirror, first of all let A B be a plane mirror which is polished on one side and not polished on the other side. Now this be an instant ray and this be a reflected ray and this be the normal to the plane. Therefore angle I equal to angle R. Now this is known as glancing angle, generally denoted with alpha, and this also known as glancing angle. Now when this instant ray goes undeviated, means tracing its own path and not affected with the mirror, it goes like this. Therefore this is the deviated angle, hence it is known as angle of deviation. And other two things, and one of the most important things we are going to learn now is loss of reflection. Here this is the angle of instance, this is the angle of reflection, and these glancing angles, and this is the deviated angle or angle of deviation. The first one we are going to learn is angle of instance equal to angle of reflection in any of the reflection which takes place on a plane mirror. And another thing is all the rays, i.e. incident, reflected, and finally normal, lies on the same plane. These are the main things which we should don't forget before going to next concepts, that is angle of incidence equal to angle of reflection, and all rays incident, reflected, and normal lies on the same plane. Let us know some formulas. First of all, we should derive that angle of incidence is equal to angle of reflection. We know that angle of incidence plus glancing angle equal to 90 degrees. Let us see once. See here, angle of incidence plus glancing angle equal to 90 because it is divided by the normal. Therefore, angle of incidence plus angle of reflection, angle of incidence plus angle of glancing equal to 90, and similarly angle of reflection plus angle of glancing is equal to 90. Therefore, angle of reflection plus glancing angle is equal to 90. Let this be the 1 and 2. We know that 1 equal to 2 as 90 equal to 90. Therefore, angle of incidence plus angle of glancing equal to angle of reflection plus glancing angle. Therefore, this and this will be cancelled, and hence angle of incidence equal to angle of reflection. And another one, that is from, we know that angle of incidence equal to angle of reflection. Let this be 3, and from 3 angle of incidence equal to angle of reflection. Therefore, I plus D equal to 180. Therefore, 2I plus D equal to 180. Therefore, D equal to 180 minus 2I. This is one of the most important formula used in ray optics. And then D by 2 equal to 90 minus I. Therefore, D equal to 2 into 90 minus I, and D equal to 180 minus 2I, and hence I equal to 90 minus alpha, as D equal to 180 minus 2I, 180 minus D equal to 2I. It turns into I equal to 90 minus D by 2. Here D by 2 can be said as 90 minus I. Therefore, I equal to 90 minus alpha. Guys, now let us know about multiple reflections between two plane mirrors. Let this be a plane mirror, and this too be a plane mirror, and let angle theta. Now, when a light ray is incident on one of the plane mirror, it gets reflected, and this reflected ray acts as incident ray for the another mirror, and this incident ray gets reflected to the other mirror. Hence, number of images will be formed. Therefore, if two plane mirrors be kept at an angle of theta to each other, the number of images of a point object kept between the two mirrors is given. Like, if the position of the object is asymmetrical with respect to the mirrors, then n equal to 2 pi by theta minus 1, and if 2 pi by theta is even for all positions, is even, and 2 pi minus 1 if odd. Therefore, here n equal to number of images formed. Therefore, let us take theta equal to some 30. Therefore, theta is 30 equal to even. Therefore, 2 pi equal to 360 degrees. Therefore, according to formula, 360 by 30 equal to 12 images are formed if asymmetrically there are 11 images formed. This is the end to our session, and we will talk or discuss about many other things like spherical mirrors, concave lenses, convex lenses in the further classes. And don't forget to subscribe us for more. Thank you.